Good morning, students. This is Anjankumar from EC departments. I would like to explain the subject of microwave engineering as we already discussed in the last lecture, that is properties and characteristics of a microwave, that means waveguide. Clear? So that is incomplete audible, that means audio record. Okay, why I am stopping in the last lecture suddenly means some expressions are there, so that's why that is not possible saying in audio lecture. So that's why I'm preparing the notes for remaining lecture. So that's why I'm preparing now video lectures. Okay, the next topic is rectangular waveguide. Okay, so before going to this topic, once again I'm remembering the previous topic is advantages and applications is over, and the introduction part of microwave engineering is over. So in that, what we discussed, the microwave spectrums and microwave bands. So which band is known as L band, that means which frequency range is known as S band, and which frequency is known as W band, and in which frequency band is known as KU band, and in which frequency range is known as S band, whatever it may be. Okay, so corresponding this frequency bands applications also we already read. Okay, and one more, the properties and characteristics of waveguide is also over. Next, the main important topic of first unit is rectangular waveguide. Okay, so before going to this topic, the outline of rectangular waveguide I'm saying. So first of all, structure of rectangular waveguide. So what is the structure for rectangular waveguide is the first outline, and next second one is the, so what are the modes are used in this rectangular waveguide. Okay, and that is the second outline. And as to go for, so what are the condition, so what is the condition for wave propagation in rectangular waveguide. Next, so what is the cutoff frequency, and what is the cutoff wavelength. So how to find the cutoff frequency and the cutoff wavelength, just we have to know the expression for that. Okay, in this lecture we are already discussing. Okay, and next, so in this rectangular waveguides, so whether it is which type of mode, like TE mode or TM mode. Okay, in this only two modes are used, that is TE mode and TM mode. TE means transverse electric mode, and another one is the TM mode, that is transverse magnetic mode. Okay, two modes are used in this rectangular waveguide, and another third one is the TEM, that means transverse electromagnetic. So that mode are not possible used in this rectangular waveguide. So later I say why not used. Okay, in the next lecture that is also seen. Okay, and next outline, what is the intrinsic wave impedance of rectangular waveguide, that is also seen in this lecture only. Okay, so what is the phase velocity and what is the group velocity, how it is find. So that is also have two expression, just you know the expression for that. Okay, next, final outline of this rectangular waveguide is guided wavelength. Okay, what is the expression for guided wavelength for rectangular waveguide. Okay, these are all the outlines for rectangular waveguide. Actually, so what is the meaning of rectangular waveguide? The name itself, the rectangular waveguide is a hollow metallic tube with a rectangular cross section. Okay, that is shown in the first line. Okay, the rectangular waveguide is a hollow metallic tube with a rectangular cross section. In the second point, the conducting walls of the waveguide confine the electromagnetic fields and thereby the guide the electromagnetic wave. Okay, and the last point, the rectangular waveguide is characterized by its dimensions, that is width is A and height is B, that is shown in the next page, just you seen. Okay, in rectangular waveguide, this is the three-dimensional angle. Just this is considered as a x-axis, and this should be considered as a z-axis, and this considered as a y-axis. So this y-axis take like this, this y-axis again you take also like this only. Why? Because three are in perpendicular to each other, that means each angle consists of 90 degrees. Okay, that is very important condition. Okay, our topic is rectangular waveguide, so that's why I'm drawing a small rectangle, one part of rectangle, just you imagine. Okay, and this is the height of the rectangular waveguide, rectangular, that is the, this is denoted by b, and this is the width of this rectangular, this is denoted as small a. These a and b are the very important parameters in this rectangular waveguide. Okay, so coming, you seen how much this important is. Okay, so this is the structure for rectangular waveguide. Okay, so second outline is what? The modes. So what are the modes are used in this rectangular waveguide? This is the second outline. So I already discussed what type of modes are used. Only two modes are used. I initially said what is that? TM mode or TE mode. Okay, just you see, it is only allowing TE mode or TM mode. TE mode or TM mode. TE mode is also known as transverse electric mode. TM mode is also known as transverse magnetic mode. Okay, this is the shortcut names of transverse electric and transverse magnetic. Okay, so the TE mode is based on the voltage wave, and the TM mode is also based on the current wave. Okay, so the rectangular waveguide does not allow the TEM mode, that means transverse electromagnetic mode. Oh, okay, so which allows only these two, and this does not allow this one. Okay, these 2 points are very important. Okay, in the next topic, in the next lecture also, seen the dominant, what is the dominant mode and what is the degenerate mode. The two topics are very important also. Just you introduction, that means here TE10, TE suffix 10 here, it is known as MN. Okay, TEMN. Where it is M? Just you imagine in this diagram. So width, M said already, A is the width. So this known as M. So the height of rectangle is B. So this known as N, small n. So these two are the dominant modes for a rectangular waveguide. Okay, just to imagine. Okay, where it is taken. So TE, I written already, TEMN. So in this format, so TE10, you take a TE. TE10 is only existing in this particular mode, that is TE10. Okay, TE10, the dominant mode for rectangular waveguide is the TE10. Okay, where M is 1 and N is 0. Okay, just you see. Next, what is the next outline? So what are the condition? So what are the condition for propagation of rectangular waveguide? So what type of conditions are required in this rectangular waveguide? That is the phenomena of this one. So condition, just you see the condition. The basic condition for wave propagation in rectangular waveguide is lambda c is greater than lambda naught, where lambda c is the cutoff wavelength, and lambda naught is the operating wavelength. Just you see, the cutoff wavelength is always greater than the operating wavelength. This is the first condition. This is regarding wavelength. Okay, so this expression can also be in terms of frequency. Okay, that is seen in the next page. Okay, the condition for wave propagation in rectangular wave, this is the another form, in the form of frequency. Okay, Fc is less than F naught. In the previous equation is what? Lambda c greater than lambda naught, but in this Fc is less than F naught. Fc here, Fc is what? Cutoff frequency. So F naught is what? Operating frequency. Okay, so whereas in wavelength, lambda c is greater than lambda naught. Coming to the frequency, lambda c is less than, Fc is less than F naught. These two conditions are very important, just to remember. Okay, which type of conditions are used for cutoff wavelength and which type of condition for used for cutoff frequency. These two are very important. Okay, just already you know. So what conditions are used for rectangular waveguide? Okay, so what is the equation for that both cutoff wavelength and cutoff frequency? That is known as formulas for calculation of Fc and lambda c. Fc means cutoff frequency, lambda c is known as cutoff wavelength. Just you know the two expressions for lambda c and Fc. Okay, the formula for cutoff frequency cutoff wavelength lambda c is equal to 2 into ab by square root of m square b square plus n square a square. Already you know m and n are the dominant modes, that is m and n. Next, b and a are the notation for rectangular waveguide. That means width of rectangular waveguide is a and height of the rectangular waveguide is b. Okay, these two are already discussed in the structure of rectangular waveguide. Next, go for the cutoff. Just in this equation you observed, the cutoff wavelength of TE10 mode, the cutoff wavelength for TE10 mode. Just you see, so in place of m you simply substitute 1, in place of n you simply substitute 0. Okay, that is TE10 mode. Okay, TE10 mode, what we are getting in the final, 2ab by square root of, in place of m 1, b square is remaining same, plus n square, n means this term is 0. Okay, why? Because n plus 0. Okay, this term is 0, 0 plus m value is 1, 1 square into b square is b square, so 100 root of b square value is b. Okay, final 2ab by b, so b should be cancelled, so what is the remaining? We are getting 2a. This is the cutoff wavelength for TE10 mode. Okay, just you remember what is the cutoff wavelength for TE10 mode. Okay, just 2a. Next, to go for formula for this is lambda c is over. Next, to go for fc. Fc means cutoff frequency. What is the formula? The formula for the cutoff frequency fc is equal to c by 2 into under root of m by a whole square plus n by b whole square. This is the formula for cutoff frequency. So just you simply above the expression you you do the cutoff frequency for TE10. Just you simple, in place of m you substitute 1, in place of n you simply substitute 0. So this is the 0th term. Clear? This is the 0 and m value is 1 by a square. Okay, that means under root of 1 by a square means a. So finally we are getting c by 2a, c by